We hope that you enjoyed your long weekend last weekend. I'm Shawn Routhier. I'm a senior security engineer at Blizzard Entertainment, and our Splunker in chief of the user group is Dave Urban, senior sales engineer. So, quick agenda: we'll have the announcements. I will do a presentation on monitoring users, and then a quick closing and Q&A. So, for the announcements, the next user group is scheduled for June 30th. Our John Nussbaum is going to be doing a presentation on dashboarding tips and tricks. The following user group meeting will be July 28th. We're trying to keep the cadence of the fourth Tuesday of the month. And the topic is to be determined right at this time. If you are interested in presenting at a future meeting, please feel free to email Dave and we can get you slotted in. We have a user group channel on Slack. It is the SoCal user group, and the user group's website has been updated for the Southern California user group. So there will be no more just ad hoc email announcements. Everything will be managed through the Splunk user group portal. Presentations and links to recording will be made available when we get them. For full disclosure, there has been a few technical challenges on getting the previous recording uploaded to YouTube. So we are still working through that, but we intend to get that up still as soon as possible. So again, we'll do another call for use cases. If you've done something particularly interesting or fun with Splunk at your work, we kind of want to hear about it. And for month to month, we'll pick a use case, kind of share it, and Splunk will mail you some swag. You can either email Dave or myself for more information, or if you have use cases that you'd like to share. And now let me change over to my presentation. So no, first and foremost, no Blizzard presentation is incomplete without a massive amount of graphics in it. So hopefully you'll enjoy that. But really, I wanted to kind of showcase what we do at Blizzard on how we monitor our users, how we try to be tactful about it, and how we remind users to do the right thing. Also, what kind of limits and restrictions that we have, and kind of the thought process behind it for forcing best practice, whether the users want to or know that it's happening to them or not. So unless you're on the red team, users typically are not malicious. They just want to do the right thing. And at Blizzard, originally we had a very hardened administrator stance, and it didn't really get us too far. The old adage of you attract more flies with honey than vinegar really is applicable here. As Splunk has grown at Blizzard, we've really become a service that the entire company relies on for some critical services. So we've really had to kind of adjust to being not only engineers, but also being at least somewhat customer focused. So we want to be that anchor of knowledge for the company for Splunk, but we also want to be polite while we're doing it. And generally, users comply with what we ask of them. They're not doing inefficient searches or doing a map with max searches equals 1 million through, like I said, malicious intent. It's just generally they don't know any better. So we've tried to provide them docs or answers pages, and some users do require that little bit of an extra mile of providing that sound reasoning of exactly why we have that in place. For example, sub-search limit is default to 50,000 events. We've increased that, but some users want to know why we didn't increase it to 1 million or 2 million events, because their particular use case requires it. So it generally allows us to educate the users on either what they're doing wrong or what they could be doing better. And I'll kind of highlight some of the ways that we automatically remind the users that maybe the search behaviors that they have are not the best. And it does use a little bit of not naming and shaming, but it does kind of make them aware that we're aware of their um, disruptious activity, or inefficient searches. And another thing I've learned at Blizzard is users tend to be bad at communicating their intent, which is not a slight against them. It's just a lot of times users' frustrations comes from misunderstandings, and really that gives us an opportunity to educate them and really solidify the three engineers we have at Blizzard as the experts of the product. It helps build trust, and really when the users trust us, they include us in discussions with the PMO right at the start, or it allows them to say, hey, something's not quite right, and just hit us up on Slack. So it really helps us help them when that trust is built. And this whole talk's not just going to be slides and memes. I'll get into some SPL. But before that, there are limits and restrictions that we do have at Blizzard. It may not be unique to Blizzard, but it's definitely what we found is the best practice for ourselves. So the first and foremost of making an efficient search is specifying an index and source type. And we really force this on our users by having the indexes that are searched by default only be an index called nothing. And the nothing index has no inputs. It's effectively you search nothing. If you just type in an IP address or a username, it's going to return no results. So it forces the users to understand what data is in Splunk, what source types, what indexes, what's available to them. And then through role-based access, we, of course, just least permissions the users to what they need. The next thing that we have on limits is we disable all time and we disable real-time search by default. As everyone in here is probably aware, real-time search occupies a CPU of a search head perpetually as long as that search is running. And we found that at Blizzard, there were double-digit percentages of users that were using all time more or less as a crutch. When the issue may not have been that they're using all time, but maybe the timestamping of the source server is wrong. Maybe it's showing that it's epoch time when it's really Pacific time, or something of that nature. So users would use all time as a crutch for, I'll get the future events and the past events, but not everyone's infrastructure is made the same. If you have something like Smart Store where you're locally caching this information, then every time a user does an all-time search against all indexes or even specific indexes with a low cache life, you're going to be returning those buckets. You'll get a cache miss and you'll return those buckets from your object store every time. And similarly, if you have a more vanilla type approach to it in architecture, then every time someone does an all-time search, you're going to be having to hit your cold bucket storage as well. Real-time permissions was a little bit easier of a sell on people because when we inherited the Splunk system a few years ago, Blizzard was in a Splunk cloud environment, and a lot of the dashboards that the users had real-time searches. They'd have a dozen or 2 dozen panels, all real-time searches, which when we brought them to our on-prem infrastructure, it was a little unsettling for the users that had these dashboards. But again, it was really an opportunity for us to educate the users that when they have a tab open with 20 panels, all real time, they're occupying 20 cores. And when you educate the user on exactly the ramifications of what real time search means, it really helps them decide whether real time is the capability that they need or not. And at Blizzard, it's taken a few years, but when we've talked to the users that use real time, we've actually come down to less than 12 people across the company that have a legitimate use case for real time searches. Other users are perfectly content with having a dashboard that has a refresh interval of 600 seconds or even 30 minutes, because most of the time when people have these dashboards, they'll open up the page, look at it, and then it gets lost in the other tabs that they have, and then they'll go back to it later in the day to look at it. But if it's refreshing every 10 minutes, then you're only occupying those cores periodically instead of perpetually. So those limits, that the time picker and the index, really force people into best practice. Um, Going to conf, anecdotally, going to conf, I've talked to some other people where even disabling all time is a very hard sell for an environment. But going back to users generally want to do the right thing. When you make the change, you'll probably have a couple of people that are vocal about the change. But in our environment, it's really helped out on some of the overhead of these systems. The last limits and restrictions that I have in these slides are default search time, sub-search limits, and the memory limits of the searches. So across all of Splunk, we have every user except admins have a 1 hour maximum for search time. This really forces the users to think about their search efficiently, because if they're not, it's going to get auto-finalized. At Blizzard, we have an average search time of around 5 to 10 seconds, so it's pretty quick. So when a user's search is auto-finalized after an hour, it really does stick out like a sore thumb. And it really does force them to come to us and say, you know, my search is getting auto-finalized, what's up? And we can work with them on making their search a little bit more efficient. The 32 gig search limit was increased from the 4 gig default, and this allows our security team and our anti-fraud teams to really effectively use like multi-index searches with stream stats and really correlate against hundreds of millions of events without having to worry about their search getting killed every time. That said, 32 gigs still does end up being a limit for some of the users. We have about 4 users that tend to hit the 32 gig limit more frequently than the rest, but we found that it's a pretty decent ceiling to, again, have users come to us and say, you know, my search is inefficient, what can I do to help? And then briefly showing you the sub-search limits. We've increased the sub-search limits from default to again help with these correlations that our users are doing. And this brings us to the automated notifications that we have for our users. We, as simple as it sounds, we just send emails to the users when they do less than efficient things. So using the send mail alert action in Splunk, you can actually use tokenization for the 2CC and BCC. And through, at least at Blizzard, we use SAML authentication. So the credential or the username is the same as their email at Blizzard. So if you have a similar setup, then it might be worth using tokenization for that as well. And with this, say I run a query that's index equals star more than 4 times a day, then at 9 a.m. sharp the following day, I'm going to get a friendly email that you see in the top there with some resources, like an app that we built in-house that gives them the resources of these are the indexes you have access to, here are the source types that you have access to. And that kind of helps them know that they've made a mistake, or maybe not a mistake, but there's room for improvement for them. And it also lets them know that we're aware of it. Because in all of these emails, it is only to the user and CC the Splunk team. So we try to encourage the user to know that what they've done is not the best, but we're aware of it. We usually don't follow up to these emails unless we see the same person coming day in and day out. And then same thing with the search memory limits. If they exceed the memory limits, they'll also get another email 9 a.m. sharp the following day. What's important about the search memory limits is not every search is user facing. Like it's not always interactive. If they have a scheduled alert or if it's a dashboard that's hitting the memory limits, then they may not be aware that there's a problem. So this alert also allows them to be aware that maybe their scheduled search or lookup builder or something failed and that they need to take action on it. You don't need to like take screenshots or anything. I'll provide the slides and all of the SPL after the fact, but this is the SPL we use for the index equals star search. The SPL you see in these slides should be pretty good to go for most of your environments. They just use audit and internal. And then this is the memory limit exceeded search. What's in the most important field in this one, I think, is the provenance field, because that allows us to kind of pinpoint for the user where their issue was. So this is a sample email from the other day of a user hitting the memory limits. So the provenance allows us to say, this was an ad hoc search, or this was a dashboard search, or this was a scheduled search. Give the specific name of the dashboard or the scheduled search, and really give the user the context that they need to kind of fix their own problem, while not taxing the resources of the Splunk team internally. And getting into a little bit more complex SPL and still monitoring the users, what happens when you have an ingest that either spikes to 6,000% higher than normal, like we've had recently, or when an ingest drops to nothing or near nothing? A lot of the alerts that I see on answers that kind of address this are really addressing it from the ingest is now nothing, which is something to alert on, absolutely. But what if it's not nothing, or just near nothing, or like I said, it's gigantic increase? As the Splunk admin and engineer in your environment, are you responsible for troubleshooting every input? And like I said before, at Blizzard, we've really set ourselves up as the experts. So when users see something wonky, they reach out to us directly and say, something's wonky. Um, what can I do to fix it? Or what can you do to fix it more accurately? And frankly, we're not responsible for every data source that comes in. More often than not, we actually just have to triage the ticket and then push it over to the network operations center to then further investigate and find a solution. And really, our solution for understanding when data increases or decreases is through scheduled lookup builders that pull metrics and then alerting. So this is the lookup builder. What this is doing is it's looking at the last 14 days through tstats of the metrics on of the count of the events coming in through a number of our indexes. You'll see that I filtered out a couple of our indexes because those are BattleNet related. And on the fourth line, you'll see that I normalized BattleNet into just production BattleNet data. What this is doing is really just collecting the metrics in a 15-minute interval for what the minimum, maximum, standard deviation averages are for these, and then filtering it down to, we only want to see the most egregious ingest points for this intake. So this is specific to our HTTP event collector, but you could also use the same kind of methodology for really anything outside of just the HTTP event collector. You could use it. I'll get into that in another slide, but so this just outputs to a CSV that's overwritten once a day. It doesn't append, just overwritten for the last 14 days. The thresholds and alert action. So we'll take that CSV, we'll throw it back into the alert, we'll join it against the current or the previous 15 minutes of data with a 5-minute delay on it, and we'll compare all of the metrics that previously existed with what's currently coming in. We use the 14-day with a 1-day delay because when there is, we found that when there's maintenance or expected cases on the network, say a game was launched or something occurred internally, then we can prepare the metrics ahead of time or prepare the alerting to either ignore that or bring it up the chain as appropriate. So in this, the where statement, it's calculating the z-score. So this is the statistics part. It's calculating the z-score, and then based off of the z-score and the thresholds that we have in there, the thresholds may or may not work for your organization. It took about 2 weeks of tuning for us to get to these particular metrics. But this is going to tell you really what the anomalous activity is, whether it's an increase or a decrease. And to kind of show that, this is the visual representation of that data. So the minimum, maximum, the limits, and then in the SPL, it will tell you how many times it would have triggered. So I unfortunately can't get into the exact numbers of what this means, but it is the anti-fraud for World of Warcraft index. And you can see that with this data, there is definitely seasonality. Over the weekends, it increases. Throughout the weekdays, it decreases. And then whether it's 4 p.m. to 11 p.m., there's an increase, and then it just seasons through the days and weeks. This is the SPL that kind of went into that. It just shows you how this thresholds are made and kind of allows you to tune these types of alerts for yourself. The other applications that you can use for that is, while we're only monitoring that particular HTTP event collector ingest, you could also use it for, say, your license usage. Break down your license usage by the individual license file that you have. If you have a multi-business unit organization, then you could say, well, Activision is now using 6,000% of their license, while Blizzard's only using 80% of our license, or you could see where those trends are day in and day out. Another one that I like is being able to do log leveling. It's really telling the amount of, at least in our environment, there are certain data sources that have perpetual warnings. They're things that are in our backlog to take care of, but they're not something that's bubbling up to the immediate use case or the immediate need to fix right now. So how can you kind of filter out that noise? And that comes back to the statistics piece. If you have a sudden increase in error messaging, crit, fatal, or emergency messaging, maybe it's something to look at, and you'll be aware of an issue before the users are aware of an issue. And then again, with scheduled searches, if there's a user running a search every minute of every day, then maybe that's something to look at as to why they need to run a search every minute. And then to get into some of our lessons learned here, these ones were particularly hard lessons for me to learn while I was at Blizzard and still at Blizzard. Average time to ingest. It's very important to educate the users on the average time to ingest, because if your source has an average ingest delay of 18 seconds in this case, if they're running, or say a minute and a half in other cases based off of the ingest type, if you're missing 15% of your data on a critical security alert that looks at last 5 minutes, then you may be getting alerting that's never actually getting that 15% of the data. So having the users understand and making available just these 3 piped commands in SPL, it allows them to understand how they need to structure their alert to say, maybe instead of the last 5 minutes, I need to look at the last 2 to 7 minutes or 5 to 10 minutes. And when we kind of push this out to the organization, we really needed users to adopt it. And by and large, users have it. It's actually a really great turnaround, because when, like I said, users want to do the right thing, when you tell them that they're going to be missing X% of their data in their alert, they want to fix that. So it's a bit of an eye chart, but this SPL would also work in your environment. It's one that I recently wrote because of a couple of users that were doing just what I said earlier. They had scheduled searches running every minute of every day or every 2 minutes, and it wasn't necessary. In fact, it was just kind of highlighting bad search practice and inefficient searches that they needed to run every minute of every day. And it allowed us to kind of sit down with them and understand their use case a little bit better, to come up with something better for them. So now, in the case that caused this SPL, it took about 3 days, but we worked with the user and restructured their entire alert. So instead of just building, in this case, it was building a KV store, dropping that data into a CSV, into a second CSV, and into a third CSV. And based off of the timing of all of those, they needed, or they quote unquote needed a minute cron to ensure that their data was up to date all the time. But their use case really only required them to have about a 15 to 20 minute response time. So we dropped everything down to about 15 minutes and restructured their searches to be efficient and run in those 15 minutes instead of taking 45 to 50 minutes to run each time. And then with only three people on the team, sometimes we just need to kind of think a little bit differently or more efficiently about some of the problems. Because we have role-based access and not everyone has access to internal or audit, we came up with some SPL to really kind of help us of a user has a, say in this use case, a user has a scheduled search that they've given read write to their entire team to use. But because it's a 24-hour shop, someone in another region changed the alert and now it's not performing the same or it's not performing at all. And with some of these, you can actually just look it up and see, hey, this alert name was changed by this user at this time, or this lookup file was updated successfully at this time by this user. If you use an app like Lookup Editor, it will always be Lookup Editor as the user in that case. So there are some gotchas with that. But then the dashboarding was particularly interesting because on one of the teams, there were two users that were one user that made the dashboard and then another user that wanted to make the dashboard better. So they'd change it and then the owner would change it back and then the other owner would change it back again, or the other user would change it back again. And really, they both were getting frustrated because they didn't know who was changing it. And using some clever SPL, we were able to tell them, hey, literally the guy that sits next to you is the one changing it. Might be best to kind of talk to them and see what's going on. So in this case, just being the arbiter of customer service for the Splunk service at Blizzard made our lives a little bit easier down the road, but also allowed the user to have a little bit more trust in us. So yeah, it was kind of a fire hose of information, but if you have any questions, I'd be happy to take them.
Hi, Shawn. This is Becky. I have a question for you.
Yeah, hi, Becky.
Hi. Yeah, so we manage a very large Splunk instance, so I'm very excited to join the Irvine user group. I'm actually the co-organizer of the San Francisco Bay Area user group. So this is a great talk, and we have all kinds of user behavior. So I'm going to steal some of your ideas. I especially like the fact that the emailing of people if they do index equals star, n times in a day, just so they know, sometimes people, they don't know. A couple of things that I'd run into, you mentioned the lookup thing. One thing that I find is that people will create a lookup file and then they share it publicly. And so it's there and it's 3 months old. Often people will name it something so you at least know what team it belongs to, but sometimes you don't. And I wondered if you guys had to deal with that. So you kind of wonder if it's needed anymore. And you
Yeah.
can't, and I wondered if anyone had written, something to comb through the logs to say, Becky created foo on this date, I mean, sometimes our internal or audit, whatever log that's in, it's rolled off. So I don't know who created it anymore.
It's it's a great question because it's actually something I was going to include in the slides originally, but then I was like, the slides are getting a little bit long, and I didn't. There's a dashboard that was created. Forgive me for not remembering right off the top of my head, but I can provide it in the slides after the fact too. There's a dashboard that will highlight the CSV size, who created it, the last time it was updated, and the name. And I've been using that lately to be able to comb through. So previously we had some data replication issues where a user created lookup files that were 2 gigs in size. So that updated every 5 minutes. So by the time the cluster was able to actually get the data replicated across the indexers, there was another 3 in queue to actually replicate. So we were in this perpetual catch-up state. And this dashboard and kind of the SPL behind it really helped us identify which user was doing it and kind of help them in air quotes along with what their use case was on why they needed a 2 GB CSV. We found out that it was actually a little bit easier to work with them on doing a multi-index search because they were just taking events from one index, shoving it into a CSV to then later join it against another CSV. And It was just a case of a user not knowing you could do a multi-index search.
Thing we've done is you can compress them, and they're so much smaller. So you, as long as create them as dot, what is it, GZ, and then they're so much smaller. They're smaller to get replicated.
That's a great point. That's something that we haven't looked at, but I can definitely look into that. Thank you.
I had another, just another issue that I've been thinking about. We, like you, we limit people, actually not even an hour, and then they do get auto finalized, and then we can see those people that run. We let people run for 30 minutes, and if it's like 30 minutes and a few seconds, they've probably been they've all probably been auto finalized. Um, so I'm wondering, and I'm thinking about the workload management, and because I know that feature is suited for something like that. So I was thinking, maybe after 20 minutes, you lower their priority, you let them run longer. But if no one else is doing anything, then maybe maybe they could have a few hours or something, but they don't get the high priority to run the job. I just wondered if you had thought about that at all, or
It's not something that we've implemented. It's a really interesting point though, because you're right. Like at the top of the hour and in the middle of the hour is probably the most concurrent searches of anyone's instances, because most people will say, I want to run this once an hour at the top of the hour. I want to run it every 30 minutes. So having having something run or at least be delayed right at the start and then low price. Yeah, that's a really interesting point. I like that.
thanks. Thanks for doing this.
Thank you.
Hey, Shawn, it's Brett. This was fantastic. Thanks for sharing. I have a question.
Thank you. Yeah, what's up, Brett?
Um, so I just to add a little color to this, I was wondering what were some of the valid real-time use cases that you said you had just a handful of people who were allowed to do real-time use cases at Blizzard. Anything? Can you share those with us? Some of the
Yeah,
valid ones.
yeah, the so I briefly mentioned that we do ingest some data from World of Warcraft, primarily around anti-fraud and some security-related game data. The people that have access to real-time search tend to be the people that are doing real-time operations for anti-cheat and anti-fraud in the games. So the use case that really kind of gave the justification for real-time search was during the last WoW expansion launch. People wanted to see in real time who is leveling the quickest, who is gathering the most resources, who is doing X at Y given time. So the dashboard ended up making its way up to executive leadership, but also as kind of a side bonus, um, we found that there were a few users that were kind of cheating the system and kind of exploited a lesser known way to gain experience. And in the expansion, they gained, I think, 2 or 3 levels within 10 minutes of the expansion launching. So having the users with real-time search on those dashboards allowed us and the anti-cheat team and fraud team specifically to find those users, action their accounts before there were really issues that kind of rippled through the game. Because in the game, for context, in the game, the person who reaches the top level the quickest will get an achievement on their account. That's difficult to remove or give to someone else. So having the ability to see who is leveling the quickest and action their accounts, it prevented uh, possibly a PR issue if it hit Reddit or something. So use cases around live operations is really what we dole out real-time search for. If it's not directly applicable to real-time operations, then usually we'll try to not convince, but we'll try to nudge the person more towards you only need a every 2 minutes, or even you just need the dashboard to refresh every 1 minute. Just something that's not occupying the CPU's perpetually.
That's awesome. And I just started World of Warcraft again over the weekends with my daughter. So I'm not a very fast. I'm not up leveling very fast. And also, Becky, so glad you could join. Northern California is infiltrating the Southern California user group here. And then final question, Shawn, of you and Michael and Tommy. So you're clearly the good cop. Who's the bad
I'll be careful since my boss is also in this chat. No, but really, we try to be the good cop where it makes sense, and the bad cop where it also makes sense when we have a very valid reason why we need to be the bad cop. Um, like even as early as about 2 hours ago, someone reached out to me over Slack and asked me, "Hey, can we do X with Splunk?" And I I told them that I'm really supportive of the idea, but it's something that I need to run up the chain. And once I said that I needed to run it up the chain, they kind of backed off a little bit. And they're like, oh, maybe it's not that important. I don't want to prioritize this work over your operations work. But another another bad cop situation was later last week, we got a request for um, custom emoji. And as cool as it would be for individual game teams to be able to put in like the Hearthstone logo or the WoW logo, it's something that we would need to kind of do a hacky job with Splunk to get integrated into our system, and then we would need to support it over however long those emojis are the current ones. And um, if we do it enough, we kind of set the precedent that now custom emoji is a service that we offer. So we kind of, in this case, used Splunk as the bad cop, as this is not a supported system from Splunk. Even though we could probably do a hacky job of getting it together, we kind of used you, Brett, as the bad cop there.
Yeah, happy to always be your bad cop, especially when people are running index equals star and all-time searches.
It's a good point though. It's not often that we have to be the bad cops because, like I said, users generally want to do the right thing. So when it's something that we can't support or it's something that um, is not necessarily supportable, then usually when we explain to them the difficulty of getting it implemented or why it's a bit of a challenge, sometimes they'll back down. But if it's really important to them, then they'll actually justify as to why it's very important. And back to, I think, the first content slide, sometimes users are just bad at communicating. So maybe we'll get a ticket saying, I want custom emoji, but really what they're looking for is they want a new app icon or something, which is definitely supported through the development docs. So,
Sounds like there's a. Yeah, this is good. I'll pass. Who's up?
thank you, Brett. Um, did anyone else have any questions or comments?
Hey, Shawn, this is John. Great presentation, great information that you've put together here. Question for you, what might some of the performance implications be or have been that drove you guys to implement some of these practices within your environment? Were you guys seeing a lot of pain with user experience? Could you just give us some insight into what you guys might have been seeing before implementing this stuff?
Yeah. So in the case for back to Becky's point, in the case for the CSVs and where we had 2 GB CSVs, when the cluster is in a perpetual catch-up state, it actually has some lasting implications on the ability to search data effectively. So in this case, this user had the lookup table that was referenced by a handful of searches that were mission critical to a business unit at Blizzard. but because the cluster was in a perpetual catch-up state, if you ran one search on if a user was load balanced to a search head and they ran the search, they would get different results from user B who was on a different search head. So having the inconsistency of results as well as the cluster constantly throwing warnings and errors that one indexer is 2 versions behind of the knowledge object bundle, while one of them is at the current knowledge object bundle. It really had some kind of weird implications on searches across the cluster. As far as performance for, say, the all-time change was actually something that we did fairly recently in the last 6 months or so. And it kind of was driven to keep it in place even after some user complaints, because the users that were using all time didn't need to be using all time. And just for context for everyone else in the chat, we only have hot and warm buckets. We actually don't have a second storage for cold buckets, so everything is on fast storage for us. And while it's not directly applicable to having performance hits for that storage or cache misses or something, there definitely was a level of, we just want the users to do the right thing. And being able to specify earliest and latest, or being able to identify when timestamps were wrong is a much better alternative than just having the users take the quick way out, which is all time. So some of these limits really are in place to kind of help the users having us help the users help themselves, because we have almost 1,000 users at Blizzard of Splunk, and we can't be omnipresent of every user and what they're doing. So being able to kind of monitor generally what these users are doing kind of gives us the understanding that when we do have an operational issue, we can troubleshoot pretty quickly on what user caused it, or what user practices may be impacting that as well. I hope that answered your question.
Yeah, definitely did. And then in terms of continually enhancing the detections for user behavior, do you have thoughts in terms of what you'll be doing next?
The next kind of road we're going to be taking with a lot of these statistics is actually more towards the security context. So the ability to automate statistics around ingest really is directly applicable to the security context of say what user is RDPing to systems after hours, or what X use case has Y implications, and being able to kind of map out these use cases and build more smart alerting instead of just Boolean, here's an indicator, this is bad, detect on the bad. We can kind of get this behavioral analytics behind it to say, this user has never RDP'd to this system before. By the way, it doesn't look like they're active on any means, and the RDP session failed 10 times beforehand. And really collecting all of those metrics would allow us to have less false positives, but also give our SOC a little bit more fidelity on what they took action on. So to answer your question, the next use case is actually more towards the security context versus user monitoring context, or Splunk user monitoring context.
Awesome.
So thank you, John. And thanks to everyone who took time out of their day to listen to me talk about these topics. And thanks for supporting the Southern California user group. It's great that each time that we do this, we have a handful more people join in, and we keep seeing the same names month after month. It really is great to see the kind of the community coming together and sharing information and really being around for each other as resources. So thank you everyone for taking the time out of your day, and I'll give you back about 10 minutes of your day here. So have a until later this month. I hope you have a great month. So stay safe.